Dynamic programming problem in operation research. Now let us see the introduction of dynamic programming problem. Many decision making problems involve a process that takes place in such a way that at each stage the processes depend on the strategy chosen. Such type of a problem is called dynamic programming problem. Dynamic programming problem is concerned with the theory of multi-stage decision process. Mathematically, a dynamic programming problem is a decision-making problem in n variables, the problem being subdivided into n subproblems, that is segments, each subproblem being a decision-making problem in one variable only. The solution to a dynamic programming problem is achieved sequentially, starting from one stage, that is initial stage, and moving to the next till the final stage is reached. And next, we are going to see decision theory and Bellman's principle of optimality. A multi-stage decision system in which each decision and state variables can take only finite number of values, which can be represented graphically by a decision tree. Circles represents nodes corresponding to stages, and the lines between circles denotes arcs corresponding to decisions. The dynamic programming technique deals with the search situations by dividing the given problem into subproblems or stages. Next, Bellman's principle of optimality states that an optimal policy, that is a set of decisions, has the property that whether the initial state and decisions or the remaining decisions must continue an optimal policy with regard to the state resulting from the first decision. Next, we see the applications of dynamic programming problems. So many applications are there for dynamic programming problems. Some of applications are given. First one is production. This technique has been used in production, scheduling, and employment, providing successful in the face of widely fluctuating demand requirements. The second thing is inventory control. It is used to determine the optimum inventory level and for formulating the inventory recording rules indicating when to replenish an item and by what amount. Third one is allocation of resources. It has been employed for allocating the scarce resources to different alternative uses, such as allocating salesmen to different sales zones and for capital budgeting, processing, and etc. The algorithm of this problem is characterize the structure. That is, characterize the structure of an optimal solution. Second thing is recursively define the value. That is, recursively define the value of an optimal solution. Third one, compute the value. Compute the value of an optimal solution in a bottom-up fashion. Fourth one, construction an optimal solution. Construct an optimal solution, computed informations. Thank you.